Hi guys, my name is Behruz. Welcome back to the Rust blockchain tutorial series. Today we are going to do a little bit of optimization for the persistent layer of our application. Essentially, we want to create something called an unspent transaction output set. As our application scales out and as we have more and more blocks getting added to our DB, this process of trying to check every single transaction become more and more inefficient. If you look at Bitcoin, for instance, the amount of space that all the blocks inside of Bitcoin will take upon a disk is approximately more than 4 or 500 gigabytes. This means to just validate a transaction, you need at least more than 4 or 500 gigabytes worth of space for Bitcoin. At least that's what I would mean if their system worked like ours did. The solution to this problem, however, is to only really index the unspent outputs and then search through those unspent outputs. Okay, let's go to the TX file and implement this structure. First, we need to create a new structure and call that TX outputs. This will be contains an array of transaction outputs, and we can use this to identify our transaction output and then sort them by unspent output. Now we can go and create the main structure for our unspent transaction output set. So create another file, UTXO set.rs, and then we'll just create another structure which we'll just call UTXO set. The UTXO set contains a blockchain field, and that's it. That's it. This allows us to access the database that's connected to our blockchain, and then we can create a new layer inside of the database which will have just the UTXOs. Before we go further with the running logic for our UTXO set, we need to modify our blockchain methods a little bit, because some of those methods are going to be ripped out of the blockchain file and then put into the UTXO set file. And we also want to change this particular method which is going to stay on our blockchain, so that it corresponds with that output structure that we created, rather than passing back just an array of transaction. So instead of taking the public key hash, we'll make it so that takes in nothing. And then return type will be a hash map where the key is a string type and then the value is a transaction output. Basically, we want this function to go through all of our transaction and find all of the unspent outputs in those transactions. So first we need to create the two maps. Then we need to, instead of the use find unspent transaction, we need to walk through entire of blockchain and use our iterator to walk through to our blocks, more specifically iterate through each of the outputs as before we did here. So let's remove these two lines and add these two line here and another bracket for get rid of the error. So instead of use to check can be unlocked with this address, and we already removed the address from the method, we just need to create another structure for this method. So we remove this for line and replace with this. Okay, as we walk through to our value out, first we need to check is already is in a spanned TXOs. If it exists with this specific transaction ID, we don't need to continue. We don't need to add them to UTXOs. Then we check a UTXOs with the transaction ID. If some, we just need to push to the outputs with this right index from the value out and clone the value out. If none, we just need to create a new TXT outputs with the clone of the value out with the right index, and the ID must be the transaction ID. Then we need to check if our transaction aren't Coinbase transaction. Then we want to walk through our value input and check spend TXOs with the right transaction ID. Then if we have already summed, we just need to push the value out. If none, we just need to insert the one with the transaction ID and wake off the value out. And at the end, we just need to return UTXOs as same before. Okay, after this implementation, we need to go back to UTXO set to create a new method to save all find UTXOs to the database. Okay, and then we need to create a reindex method to save all find UTXOs from the blockchain and walk through to UTXOs and save them to database. We use these different paths to save UTXOs. First, we need to remove all of them and open a new database with this path and save all UTXOs into the database. Let's also create an update function which will take in a block and then use that block to update the UTXO state inside of our persistent layer. First, we load the database, then we walk through the transaction from the block, then check if the transaction is not Coinbase. We need to walk through to all value input. Then inside this for loop, we create a empty TXT output. Then we need to get from the database with this transaction ID inside the value input. Then deserialize that to out TX outputs. Then we need to walk through to our outputs and check this out index is not equal to value input value out as a use size. Then we need to push the outputs with the out index. Then we need to check if the output is empty, so this value input is not valid, so we need to remove it. If that outdated outputs wasn't empty, we need to insert to the database with the serialize the outputs, update outputs. Then after we checked if the transaction is Coinbase, we need to walk through to value out and create a new outputs with the TX outputs. Then we push the all out value and clone them. Then at the end, we insert them to database with the transaction ID. Now, there is one more quick helper method that we want to create for our UTXO set before we start to take the blockchain methods and pull them into this file. This is just a method that will allow us to count how many unspent transaction outputs are inside of our set. So we first just create a counter and load the database, and we are going to walk through to our database and increase the counter, then return a counter. Okay, in the next video, we are going to move some method from blockchain to our UTXO set and complete our persistent layer for UTXOs. And then at the end, we are going to test our CLI command. See you soon.